Okay, this is a life lesson problem, and one I want you to learn here rather than learn when you break your French press, as my son broke mine, as my son broke two of mine, shall we say. Um, so we've got a knife, and we're going to drop it into a glass or into, in this case, a French press. You drop the knife in, and it's going to hit the glass and it's potentially going to crack the glass. And so we're going to look at why that is. All right. So we're not dropping it from a very high distance. We're at 1 centimeter, and we've got to convert, or not 1 centimeter. We're at 3.4 centimeters. So the height we're working with is 3.42 centimeters, which is 0.0342 meters. All right, you divide by 100 to get from centimeters to meters. Um, and so we can figure out, okay, what's the velocity it's going to be at? I gave you guys the velocity equation because I thought, I could make you go back and look this up from weeks ago, but no, I'll just throw it to you. Okay, so we know the velocity that it's going at, and that here would be v is square root of, oh, do that right, of 2 times 9.8, that's meters per second squared, times our 0.0342 meters. And you can see it's going to be meters squared over second squared. And so you're going to get a velocity out of this. I'm going to pop open Excel. Bring over Excel real quick. Actually do these calculations because I want to illustrate what we're up against. Okay, so we have our height is 3.42 centimeters. I'm going to just go ahead and convert that, divide by 100. We have g, which is 9.8. So we want the velocity, which is square root of 2 times g times the height. So you can see 0.8 meters per second, which still it's okay, right? I mean that's out there. Okay, so we now know the velocity. 0.8. I forget exactly what it was after 8.81 per second. Yeah, it's a great thing about using Excel. You don't have to write stuff down. 8.181. I'll go ahead and go 19. Okay, so we know the velocity. Let's get rid of that. Not that way. Okay, so we know the velocity. And suppose the knife takes 10 milliseconds to stop. What mass does the knife has 0.107 kilos of mass. Okay, and so we're looking here at the momentum, right? The momentum of the knife is mass times velocity. So 0.107 kilograms times 0.819 meters per second. Okay, let's go back over to Excel. Okay, so let's get the momentum. We have our mass. Our mass is 0.107 kilos, so our momentum is just going to be mass times velocity. We also know the time that it takes to stop. So if you think about it, when you drop the knife in and that's milliseconds, so to get to seconds, we divide by 1,000. When you drop the knife, it hits on its point, and it's kind of like a little spring. It bows a little bit and stuff like that, so it doesn't come to a stop instantly, but it does come to a stop in a very short amount of time. And so we know the momentum, we know how long it takes to get to a stop, and we know that the force is just going to be the change in momentum. So the momentum goes to zero. So the change in momentum, which is just the momentum we start with, divided by how long it took to get there. So we have a force here of 8 newtons. You're thinking, no big deal. 8 newtons. Voila, c'est bon. Okay, we got a force of 8 newtons. And let me go back up here. Momentum 0.087, 0.087 kilograms meters per second. And we got the force is that momentum which is 0.087 divided by 0.0109, and this is going to give us newtons, and we ended up about 8 newtons. Okay, so we got 8 newtons. That's our force we're after. What's the area? Right? The area is going to be what? Well, what do we have here? We've got 0.27 millimeters by 2.77 millimeters, right? 0.27 millimeters times 2.77 millimeters. Yep, there we go. Okay, we have all that. And so let's go put all this in. We got a length and a width. We'll call them 2.77 millimeters, 0.27 millimeters. We need to divide both of those by 1,000 to get to meters. And so now our area is just going to be the width times the length. There's our area. 7.479 times 10 to the minus 7th square meters, right? 7.49 times 10 to the minus 7th square meters, because I converted everything to meters. And so now our pressure that this knife exerts on the bottom of the glass at the point where it hits, or the bottom of the craft at the point where it hits, is our force, 8 newtons over 7.49. We'll call that 8, because then I can do the math. We've got 8 newtons. Well, I got Excel up. 8 newtons, and we've got 7.49 times 10 to the minus 7th meters squared. Okay, what's that going to get us? Let's go back to Excel. The pressure, right, is going to be the force divided by the area. So the pressure all right, there's the pressure, and that's pascals. And we want to convert this to atmospheres. So we're going to multiply this by 1 atmosphere over 101.325 pascals to convert to atmospheres. And what is that going to give us? So the conversion factor, 1 atmosphere is 101.325 pascals. So the pressure in atmospheres is the pressure we calculated divided by the pressure of 1 atmosphere. And here we go, 106 atmospheres of pressure at the point of the knife. And this is why you shouldn't drop a knife into a glass.